Okay, everyone, we'll go now on the introduction on electric drive. Uh, just to have a clue what will be covered in the class, yeah, for the topics. So electric drive. So when we talk about electric drive, what is it? Yeah, what is it? So electric drive is an electromechanical system. Well, in this case, mechatronic system intended to set into motion technological equipment. So it is talking about how to drive something by electrical force, electrical drive. Yeah, this is the drive technology. So it consists of electric motor or motors, a transfer mechanism, which is the transmission, and then the electrical energy converter and a control system, of course. Then it all combines in these topics. But of course, for this subject, we will just focus on the classification, the categories of the electric motors, what are the usage of that, the implementation, application close to whatever we desire. Yeah. And let's look at engineering system in general. I'm using this a lot because this is basically the basic system that happens in engineering. So there is a mechanism that we are dealing with, that the process that we desire. And then this mechanism is being actuated by something. Yeah, it may be hydraulic system, pneumatic system, or any other system that actually can drive that mechanism, that makes that mechanism to operate. Now, as soon as that mechanism operates, then there should be some kind of measurement about the output, the variable being controlled, what it is, what is it. So that variable being control variable, then is being sensed by sensors. Yeah. So if we are sensing it, then of course these sensors and actuators are controlled or are managed by an electronic device. I would call it brain. Yeah. So if you look at the bigger system like this, so let's say it's a car, a car, combustion engine, or electric vehicle. Then somehow the mechanism is actually to drive the shaft, the wheels, and then the speed of the wheel, the speed of the car will be sensed, yeah, with some kind of sensing mechanism, and then it will be fed back to the electronic device in the car. So, for example, if the car needs to be driven at a certain speed, then the brain somehow, if it is automatic, yeah, then it will tell the actuators, whether it might be the internal combustion engine or electric vehicle, to speed up or to slow down, so that the mechanism is as desired. Yeah. So this is basically the general diagram of an engineering system. Now, these actuators is the one that I mentioned just now. Is can be comprising of electric drive, hydraulic drive, pneumatic drive, or other mechanism that possibly existing. But in this case, we are focusing on the electrical drive, which is the electric motors or electric machines. Of course, we're not just talking about motors, we're also talking about generators. So that's why it is electrical machines, yeah, electric machines. So this is the structure of a drive system as an introduction. So when you look at it, there is this motor. This is actually the driver, yeah. So it is connected to some kind of shaft or some motion elements, yeah, that will be driven by that motor. So the motor will, of course, will be monitored, will be observed by a sensors, yeah. Now these sensors then will be fed back to the system that will also drive that motor as a consequence of the monitoring of the output result. Yeah. So this control or signal processing in here is actually the one that will drive the motor again through some power electronic converter, of course. Yeah. So there are some power input energy being supplied, and there is motion references. This is like the input. Yeah. Whatever we input to the control or signal processing, it will combine with the motion sensors, and then whatever the input that we give to the motor through the converters, and then the brain will think about something and decide and do something to the motor again. So this is the structure of drive system. Yeah, of course, motors is the main focus on this subject, but we are not related to other aspects. Yeah, which is sensor also, but we're not going to talk other aspect too much, only the motors. So this is the knowledge base of electric drive. So when we talk about electric drive, it means that it relates to other aspects. So it doesn't stand alone. Of course, it stands alone in terms of components. But when we make it work, when we put it into application, implementation, that it should be applied to other aspects such as sensors, of course, observers, more something that monitors the movement, the mechanics, yeah, to make it running smooth, the mechanical system modeling, the real-time control and control theory applied to that. So even the control will be depending upon whatever the type of motors we are using. Power electronics, yeah, the supply of the electricity. Is it AC? Is it DC? Or is it DC to AC? Like when we're talking about electric vehicles, they have the like Tesla, they have this battery, and then they have this inverter to drive the induction motor that drive the car. So there is a DC to AC converter there, and then machine theory and some utility interaction mitigation to avoid any problems in there. Yeah, so this is like the knowledge base, but we are focusing on this subject mainly on the electric drive focus. So the course focus is basically the prime movers, like I said before. So the motors for providing drive torque in machinery. Yeah, that's the point. Yeah, let me repeat this. Of course, we are talking about machinery, so generators also will be discussed. Yeah, generators will be discussed also. So both AC and DC motors and generators will be examined. Okay, and power issues in driving these motors also, some loss of power because energy efficiency is important. So it's power efficiency is more important, so it will be discussed. At least the knowledge is there, is being exposed. So when engineers or you students try to implement it later, can take that into consideration. Objectives. So hope the students that study this will be familiar with the principle behind electric motors. So AC, DC, the things that we're going to discuss, and be able to select them for a given application, as simple as that. So for example, later in your project, we have this mechatronic system design 1 and 2, and then your thesis, maybe you are going to have a project to implement something, and then somehow in that project you need to apply electrical motors. Then you just can hopefully, after studying this subject, then you know what is the case, what is the control variable, what is the type of motors suitable for that application. And as soon as you are able to do it, and then later to assemble them to take it into implementation, then objective is achieved. Yeah. So application area of motors are variable torque. So application that can have a torque as desired by the client, by the engineer. So for example, vehicles and transformation system. So how fast that you want it, how big is the load, how heavy is the load, then the torque is calculated and applied, the one that is suitable for that. Conveyors, yeah. Conveyors, sometimes they move slowly but with high torque. Lifts, yeah, like elevators, excavators, and also materials handling equipment. There are many of these, yeah. When the car assembly manufacturing, vehicle assembly manufacturing, how they handle the equipment. They use many types or many size of motors also. Second one is variable speed. So the first one is talking about variable torque. So I need motors that have this type of torque, range of torque. But this one is also depending upon the variable speed, like pumps. You know, how much flow rate that you want. It depends on the speed of the pumps. You know, mill drives, compressors, wind generators. You know, how high is the speed that can generate electricity and so on. Oh, vice versa, generate rotation. Electric vehicles, yeah, variable speed, electric vehicles. I was just talking about it. Railway, other transportation system like in mining, when we talk about mining, we need to have a adjustable speed, especially when you are carrying a different size of load, different weight of load, mass of load. So when the load is very heavy, you cannot have a high speed going up. But when it is not so heavy, then you can use a high speed. So speed is changing, depends on the load. And usually we use that series motors like that. Electric ship, yeah, ship that runs with electricity. Electrically actuated aircraft, new development now these days, yeah. So everything now is like pushing that way. Countries, even like Indonesia also is now trying to focus on the electric vehicles. Now, some government agency cooperating with Pertamina, cooperating with the electricity unit or department, government unit on that, so to create a docking charging station. Yeah, they start to do that now. So we are going that way. And the third one is position servo. So this is actually, servo means like you are following path, you are tracking something. Yeah, I was trying to find the word, tracking something. Yeah, tracking and then pointing to the the spot or to the path that it is desired. Like wire bonding machines, wire bonding, yeah, how it is being connected to one point and then move it, and then at the same time it will bond it to another point. Yeah, like this is like a very small wire bonding. Yeah, machine tools, how we can in Indonesia we call it bubut. Yeah, machine tools drive, how to shape something, how to carve something, how to make it. Yeah, and rolling mill drives and so on. Material handling equipment also, we do that in especially before I mention it, but material handling also needs some tracking, some positioning control, and automation system, of course, and robots, robot hands. It's a position control. So these are the application areas that we can apply. Just think about it when we are studying. Think about it, what the lessons can be implemented later. Yeah. So let's look at a brief introduction. I took it from some notes from I think it's from MIT. This picture. Yeah. It's just introduction that later we will talk a lot about this, because motors or machines, generators and motors, they consist of two winding, basically, stator and rotor. We call it armature winding, and we call it also field winding. Well, of course, depends on the type of motors. Sometimes, like AC motor, the armature winding is in the stator. We'll discuss about it later in details, while the field winding in the rotor. But it is different when we are talking about some DC motor, especially permanent magnet DC motor, that the rotor is becoming the armature winding and so on. So if you look at this, there are some bearings, yeah, there are some stators, there are some rotors, yeah, and where the location. So the one here on the right. So if I'm putting my laser now, this one is like we are looking it from top side, I would say, yeah. This is the top side. This is from the side, yeah. Then we can see that the rotor here, which is in here, yeah. Stator there, which is there, yeah. And then there are some air gap here. We'll discuss about what is the purpose of air gap later. This is the air gap. Yeah, where the energy is being pulled in there. That's how it can later create torque. Yeah, there. Yeah. So there is winding here, winding and winding, and there are some conductors also. Okay, and these are the shaft connected to external load. So this is when we are talking about the stator and rotor, they are actually electromagnet, if not magnet. So if they are electromagnet, then there will be windings in the rotor or in the stator. Those windings are put in slots. Yeah, so it is like a place in a slot. So they are wound within the slots like this. Yeah, this doesn't show exactly the winding, the wire winding, but it looks like that. So if you can see the rotor conductors in slots here, this can be some what shall I call it? Some I'm sorry, I forgot the word, but that's where later when we are talking about hang on. Anyway, that will be the I'll try to remember. I'll talk about it later in class. That's where we can have the magnetization happening on that slot, yeah, on that bar, yeah. So that's how it works. So when we are giving current through the wire wound around that slot, then it creates magnetic polarity. That's what create pulling and pushing reaction between the stator and rotor. So if we manage the switching nicely, then it can create rotation. Yeah, we'll talk about it more later. Yeah, and this is the variable speed drive system, more typical tractor. If you look at it again, similar to the one before, but this is the motor and there are some sensors. Yeah, when it is acting, there are some motion sensors on it. And of course, this is the motion controllers. Everything is here. So motion reference coming in, and there is the supply AC or DC, and then the power converter going to the motor. This is the common structure, typical structure of that. Yeah. So the motor is actually with the load coupling running the load, and then the sensors will sense it and then going back. So that's how the feedback mechanism happening. Okay, let's just discuss quickly on the topic focus on this course. First is we will talk about magnetic circuits and magnetic materials. This is the basic, yeah. So the introduction of magnetic circuits. So actually, when we talk about generators or motors, it comprises of circuits of magnetic circuits. Yeah, it's like a ferromagnetic material is being put in there, and then will be wound with some wire, current conducting wire. So when current is given, excited through the wire, then that ferromagnetic material, which is magnetic circuit, will be energized, will be magnetized, and therefore somehow it will create some kind of torque, pushing and pulling, and then movement happens. Yeah, it involves flux linkage, it involves inductance, it involves energy and energy conversion also. So we'll talk about the properties of magnetic materials, what is actually there. Basically, it's all ferrum. Yeah, ferrum is the focus. Yeah, that's why it is called ferromagnetic materials. Yeah, iron basically, in other words. Permanent magnets, we'll talk about it, and then application of permanent magnets materials in terms of in our machines. Yeah, second one is talking about introduction to rotating machines. So after the magnetic circuit, then we are going to go to the introduction, how the concept of rotating machine, and then how AC and DC machine actually works. So introduction to this before we go to example, the main aspect of AC machine and DC machines. And then magnetic fields in rotating machine. It should be machine, not machinery. Yeah. And then rotating MMF waves in AC machine. You see, when we have a multi-phase, then it can create a rotating MMF, rotating magnetomotive force, rotating field. Yeah. So if we have a different phase, multi-phase, yeah, just like your washing machine at home, yeah, you turn it on somehow at some stage when it is spinning, when it's time to spin, yeah, the clothes, it will spin. But you can see that your plug system is only one. So it must be only one supply, one phase supply. But how come it rotates? Yeah, either there are more than one phase, or probably there is some phase difference making that. Yeah, usually that's using capacitor, but we'll talk about it later. Yeah, and generated voltage. How much is voltage is being generated? Because we're talking also about generator here. And then linear machines. So there are machine which is linear motors. We'll talk about it briefly. And then magnetic saturation. So we will discuss, I think, in the first part about how actually magnetic field is created. Yeah, there is what we call as magnetic moments, just like electricity. How can electricity being flowed is when energy is given, potential difference is given between one end to the other end, and somehow electron is flowing. So vice versa, the electricity will flow. Similarly with magnetic saturation, and we'll discuss on that. And then some leakage fluxes. Yeah, because remember I mentioned before there is some gap. So there are some leakage also there when the gap, but gap is very important to focus the energy in that gap. And synchronous machine, and we go to AC machine, AC synchronous. We'll talk about the polyphase synchronous machines. Machines mean again, yeah, motors and generators. And then the synchronous machine inductances, yeah, reactance, equivalent circuit of that. So if we want to calculate the real current, how can we see it as a electrical circuit? And we'll discuss it a lot. Open and short circuit characteristic, steady state operating characteristic. Yeah, when it is in steady state, what we need to talk about. And also power angle characteristic of salient pole machines. Machines in synchronous, they can have a salient pole and non-salient. We'll talk about that. What is the purpose of salient pole? Salient pole is when you have the projecting again, I forgot the word. Anyway, the projecting slot, yeah, like that. I cannot find the word, but we'll talk about it more in class. Permanent magnet AC motor also we'll discuss. And then of course, each of these motors will talk about the speed and torque characteristic. Yeah, how they are behaving. And polyphase induction, still AC machines, introduction to that, and then induction motor equivalent circuit. So again, like synchronous, we have equivalent circuit for that, so that we can calculate and see what's happening actually in the in the circuit, in the winding. The analysis of the equivalent circuit, and then the torque and power by use of Thevenin's theorem. Again, our basic in electrical basic circuit theory is important to support in understanding this also, yeah. And parameter determination using no load and block rotor tests. Yeah, there are some parameters in the induction machine as well as in synchronous machine that is not designed. You know, when you design PCB board, you want to calculate your circuit. You know the amount of your resistor, the value of your resistor, the value of capacitors, and then you just find and then put it there and then calculate and then experiment easily. But in here, because we are having winding, yeah, having winding here and there, this winding actually is creating itself some inductor behavior, and it creates some kind of a new inductance or reactance, yeah, to the system. So we need to determine that, because it wasn't really given, it's just created by itself because of the design. Then we need to find it by no load and block rotor test. Effect of rotor resistance, wound and double squirrel cage rotors. So in this we have the most common one is squirrel cage rotors, but there are also wood. Yeah. So if we change the resistance, then we can change the torque and speed characteristic on that. And DC machine, sorry, it's coming with the end. So commutator action and then analytical fundamentals, the electrical aspects, the calculation of torque, calculation of the speed, calculation of the counter EMF, yeah, and analytical also fundamental magnetic circuit aspect, talking about the magnetic field, the magnetic density on that, and also permanent DC machines that we are using a lot. Students use a lot that because it is cheaper, it is easier to manage to control. Yeah, you just give value voltage and then it just run. You don't need any switching mechanism. And also speed and torque characteristic we'll discuss about it. Special motors, some motors, single and two-phase motors, and variable reluctance machines, stepping motors, and all stepper motors, and series universal motor when we talk about that. Yeah. So that will be it. I'll see you in class and we discuss more in detail. Thank you very much.